All right, welcome to a special session that we want to run during this week. And as you know, the idea of this session is to support you with some additional models and examples, basically regarding to queuing theory. So this is the Witness Extra session and queuing theory. So the purpose of this session, right, is going to be divided basically in 5 bullets, which is about to understand more about witness, learn some basic witness modeling elements now regarding to queuing theory, use more variables and attributes in order to identify some special calculation that we could do. So that's why we will be able to create some formulas and export the outputs to Excel. So we want to create 3 models. So I will try to show you step by step how to create each model. Anyway, you still have available the slide, so it's expected that for you to check those slides in advance and try to replicate those models and try to understand very well what they are doing. So the notation basically is going to consider that we have one active part A, 4 buffers, B1, B2, B3, and B4, 2 single machines, M1 and M2. And you will see that eventually in the diagrams, in the conceptualization, you will find some red arrows with some red text that mean that, for instance, all the arrows that are in the left hand side are regarding to all the information that should be included in the action and input on witness, and the arrows located at the right hand side are regarding to the action on output. So we will know what we should include. So the model that we will start creating is very simple. This is the model 1 or initial model. So basically what we have is that we have the traditional initial structure about part A arriving and then being pushed to B1, and M1 is going to pull part A's from B1. After this, M1 is going to push part A's to B2, B3, and B4, which are some buffers, and the M2, which is a single machine, is going to pull part from B2, B3, and B4. So let's create our model. So if we follow all what we know, we are going to activate our design elements. So in a way that we should be able to create our model very simple. So we have on one hand part A, right? Yeah, one buffer, machine. Sorry. Yes. Then we have 3 buffers, and the final machine. Right, this is what we know. So just to make it look more nicer, I will try to enhance this area a little, so we can do it. Yes, let's make it a little bigger. Just want to see it better. The model is going to be around this structure, so we're not going to do anything more difficult than this, right? But the idea of this set of this first model is try to create the first structure on which we will be able to add new features. So we know that this is part A, and it's going to be an active part. We still don't know the interval time. This is buffer B1. This is matching M1, as we know. At the moment, that's what we know. This is buffer B2. This is going to be buffer B3. B3. This is going to be buffer B4. This is going to be machine M2. Sorry, made a mistake. As you know, witness all the times try to maintain the consistency between names, variables, attributes, their connection, and so on. So be sure that if you made a mistake, witness is going to let you know uh, at least where is the mistake, right? A different thing, as you know, is that if the model is really consistent. Right, so now I'm going to start doing the connection. So we know that graphically we can do this very simple. So part A are going to be pushed to B1. Then M1 is going to pull parts from B1 like that. So M1 is going to push all their parts to B2, B3, and B4, and M2 is going to push part from B2, B3, and B4. Finally, M2 is going to send all their parts to ship, as we know. See? So at this very moment, this model is very simple, it's very basic. Actually, we can check the element flow if we want to check the consistency of this, and then this is more or less how the parts are going to be moved, right? But as you know, this is only a graphical thing. Witness doesn't depend on the graphical elements really. It's more important the logic about this. All right, so if we have a look again to our slides, the slide says that that's our structure more or less. This is how the model should look like. So you should have got something very similar. Part A, B1, M1, all the buffers, and machine 2 at the end. So what is going to happen is that part A is inactive, right, and arrives every 1 minute in lot of 1. Machine 1 is a single machine and has a cycle time of 1 minute. M1 push A to B2, B3. M2 is a single machine, has a cycle time of 4 minutes. And then M2 pulls from B2, B3, and B4. And once M2 finishes, it processes send A to ship. So it's 1 minute, 1 minute of cycle time, and then 4 minutes. So this is information that we were missing. So the inter-arrival time, sorry, is 1 minute. The cycle time here is 1 minute. And the cycle time from this is 4 minutes. So as you can see, I make this on purpose because the idea is try to see how this queue behaves, right? How this buffer behaves, because we know that this part arrives every 1 minute, and those are processed in here in M1 every 1 minute, but M2 process them every 4 minutes. So eventually here we should see a queue, right? So element should be waiting in those buffers for parts being processed in M2 in order to carry on with their process. So of course we need to see what happened, right? So that's why we're going to use this simulation. So if we follow the slides, we should run the simulation by 100 minutes. So let's see what's happened. So I want to check this. I want to run the simulation for 100 minutes. In addition, we're going to add very carefully the animation just to see how it looks like. And we're going to check also the units, because I'm saying all the time minutes, but I don't know if they are minutes or not. So I'm going to go here to model in clock. So here we say that it's custom, so oh, it's not in minutes really. So now I'm going to be sure that this is in minutes. There, minutes. Very good. Alright, so now I'm ready to run this model. The clock here is activated, so I'm sure that the model is going to run by 100 minutes. And I should see the graphic. So what I'm expecting to see is that part should go to BM2, and whenever M2 will be busy, we will see that in that stage color. Part should be waiting in those buffers. So let's see what happened. So we can see that part are queuing, but something is happening here, right? Because what I can see is that even if I have 3 buffers and M1 is pushing to B2, B3, and B4, right? For some reason, all the parts are going to B2. So there are no parts in B3, there are no parts in B4. This may represent that sometimes some workstation in real life, like cash machines, for instance, or different servers in a bank, or I don't know, cashiers in restaurants or supermarkets, maybe are not well balanced. So what I can see from this model is that all the parts are queuing in one place and the others are just not used, right? So interesting, because even if the model says that parts are going to be pushed to B2, B3, and B4, and parts are going to be pulled from B2, B3, and B4, for some reason, parts are only going to B2, right? And that is regarded to this notion of discrete event simulation that we talk in the lecture, which means that all those events are in a list. So for witness, really, there is only one buffer available, which is B2, and we are not saying nothing against it, because as long as B2 has capacity, as long as B2 is not blocked, right? Uh, M1 is going to push all the part to B1. So eventually, what we would like to do is try to check this exercise and check if what we could do in order to maybe try to model something more realistic, like I don't know, maybe try to select some buffers, try to represent the fact that if someone see that a buffer is too busy, maybe I could go to other, which is less busy, because maybe I would like to wait less time, you see. So that's very important. So we can see that the simulation is about to finish. So exactly. So now maybe I would like to see my statistics. Wait a moment. So if I see, for instance, my statistics, I know that there enter 101. So let me see what happened with the buffers. Here, all the buffers. So I can see that in B1, which is the first one, 101 has arrived. In B2, 100 has arrived, right? Total in, out in B2, in B1, sorry, is 101. So all the part that got into B1 got out. And just a quarter from B2 was able to get out the system. So that means that there is a huge bottleneck in M4. Sorry, in B2. But also we can see some charts. For instance, we can see more or less here. Let me see here. We can see that, for instance, that B1 is red, B2 is green, B3 is blue, and B4 is light blue. So only I have information from B1 and B2 and nothing from B3 and B4, right? So this is something that eventually we would like to fix. In the slide, there are some questions that are expected that you may answer. So once you run the model, right, you may get answer to this. How many parts has arrived? You know that we're 101. For how long they are in the system? Well, we still need to find that into the report. So you would like to see for how long parts are in the system. So it's just about to click on the report, the statistics. So we'll see that here. So the average time, so in average part are 38 minutes till they get in, till they get out, right? Of course, that we know that most than the 70% of parts are still queuing. So that information is only representative for only for those 24 parts that were able to go out, because 77 are still inside. Yes, so this average time is just regarding to those 24 parts. So eventually, in order to know how long they really spend in the system, maybe we should run this model for longer in order to really get that figure for real for the I don't know, for the 100 parts or so on. Right? So I really hope that this exercise would have been useful to see that in order to model queues, right, it's very important to analyze what is happening with the report. All right. So in the next video, we will add new features in order to collect the statistics. That is what we want to do. And after that, we will create another model in order to add the rules. So that means that in order to do a proper model, we need to prepare them properly, because after this, any change that we will do, the statistics will be collected in the same time, and then we would like to compare them. Thanks.